Okay, so this is 2.4 properties from algebra. Let's start. So we have the addition property. If A equals B and C equals D, then the addition of A and C equals the addition of B and D. I want you guys to notice that they grabbed the letter from A and the letter right here, and the C and the C. So the addition of one letter combined with the other is going to give us the addition again of one letter combined with the other. Now do keep in mind what I just said. They grabbed one letter of each and put them together. Now, we have the subtraction property, which is if A equals B and C equals D, then the subtraction of A minus C equals the subtraction of B minus D. Again, they grab one letter of each, combine them for both of them. Now we have the multiplication property is if A equals B, then A equals C. Sorry, the multiplication property of A equals B, then A times C equals B times C, and C does not equal 0. The reason it does not equal 0 is because if you multiply by 0, it's a multiplication property of 0. There's not a 0 in the name, you cannot multiply by 0. Also, the division property we have if A equals B, then A plus C equals B plus C. C does not equal 0. Again, in this case, and in any case for division, the number you are dividing by, like at the end, cannot be 0. If you plug that in the calculator, even, it's going to give you an error. So you know it's not allowed. Okay, now we have the properties of equality. Guys, these are important. This is how you guys are going to solve the first proofs. We have the substitution property, which is if A equals B, then either or A or B may be substituted for the other in any equation or inequality. Now here they give you an example. If 2A equals 10, then 2B equals 10. I'm just going to say, and I'm going to grab this first equation, and I'm going to solve for A. I'm going to divide both sides by 2, and I'm going to get A is equal to 5. If I substitute this A into here, I'm just going to do 2 times 5 equals to 10. Therefore, 10 equals to 10, showing that the property is true. Now we have the reflective property, which is A equals A, which is just one thing is going to equal itself. Then we have the symmetric property is if A equals B, then B equals A. Again, the symmetric property, all you really do or all that's really happening is they're flipping it, but it's still going to equal each other. Now, the transitive is if A equals B and B equals C, then A equals C. Now, we reviewed this for the quiz. I don't know if you guys remember. This is kind of like the syllogism law that we can take away the middle part and it's just the first equals the third. But we also reviewed this earlier on the last slides. Does anybody have any questions with this? Okay, so there's no questions. I'm going to start with a distributive property. Now, it's going to be the sum and then the difference. The reason there's 2 is because of the answer. But let's start with the sum. If A times B plus C equals AB plus AC, this is just a distributive property. I'm going to multiply A times B plus A times C. It's the sum because the answer gives us a plus. Again, that plus we get from this sign right here and whatever the sign of A is. In this case, they're both positive, so they're going to stay positive. If they both would be negative, they would also become positive. The only way it's going to stay negative is if you multiply one negative and one positive. So we're going to do the same thing for the difference. So distribute it in the difference. We're going to multiply A times B and A times C. We're going to get AB minus AC. Again, this negative applies based on the signs of A and C. Now we have the reflective properties. So this is the properties applied to angles and segments. We have the reflective property, which again, DE equals DE, so itself equals itself. Or in an angle, angle D equals angle D. We have the symmetric one, which is if DE equals FG, then FG equals DE. Again, the only thing that really happened right here was these two were flipped for the second part. Same thing applies for the angles. If angle A equals angle B, then angle B equals angle A. Again, all that was done, it flipped. Now the transitive is if AB equals CD and CD equals EF, then AB equals EF. Again, the first one equals the last one, and we can get rid of the middle one. It also applies for angles. If angle A equals angle B and angle B equals angle C, then angle A equals angle C. Again, same thing. The first one equals the last one. And since angle B are equal to both, then we can get rid of it. Now guys, I know for example 1 you have congruence as the last word. Please change it to equality. So for example 1 is justify each statement with a property from algebra or a property of equality. Alright, so for the first one, as I was saying, these two are flipped. AB is flipped with CD. So we're going to get the symmetric. Property of equality. Now for property of equality, I'm just going to write POE. Usually I don't have enough space to keep writing, so I'm just going to keep it as POE. For the second one, we notice that they distribute this 3 to the x and to the y. Obviously, it's a distributive property of POE, so I'm just going to write distributive. Now, I'm just going to write sum at the end to be consistent with the PowerPoint. Now, for 3, we have if 2a plus b equals 24 and b equals 4a, then 2a plus 4a equals 24. This is a substitution one. You see that b equals 4a. They grabbed this b and plugged it in to give us this equation. So they substituted the b for a 4a. So this is the substitution. Property of equality. Now for the last one, we have if x is divided by 3 equals 12, then x equals 36. All we really do is multiply both sides by 3 in order to get rid of that fraction. And that's how we get the x equals to 36. Now, because we multiplied, is the multiplication property of equality. Okay, guys, so here we're going to justify each step. I want you guys to understand this is the beginning of proofs. We're just going to do it with algebra to get the hint of how it's going to work. I'm just going to draw a line like this and a line like this. So this is the statement. And this is the reason. Now, this is the original equation. So because it's the original equation, it's always going to be a given. So you always start with the given with the proof. It's the original thing they give you, that's a given. Now, let's take it one step at a time. First of all, from the first step to the second, to get there, all they did was multiply the whole equation times 3 because they wanted to get rid of this fraction. In doing that, we're going to get the multiplication property of equality as a second step. Now, from the second to the third, they distributed this 3, so it's a distribution property of equality. Afterwards, they added this 12x on both sides. Now, because they're adding instead of subtracting is the addition property of equality. And lastly, they divided that 14 to get the final answer. Therefore, we end up with the division property of equality. Now, I call this a proof. Well, it's a proof, but this is an algebraic proof. You write every single step down in order for it to work out properly. I misspelled multiplication. Okay, now that I wrote multiplication properly, it's again the same steps in the order you do to solve for what they're asking, but you have to write every step down in order for the proof to be correct. So this next one, I want you guys to try it out. I'm going to set up the statement and the reason the same way you have it on your PowerPoint, which is slightly different. Now, this is how you guys have it in your PowerPoint. From the first to the second step, what they did was they combined this negative 4x with this 3x. They added that 4x. It's going to be the addition property of equality. Now, in the next step, they tell you that they want you to subtract the property of equality. So for us to subtract, we're going to have to move this 2 to the other side, subtracting it. So we're going to get that 7x equals 21. And lastly, from 7x equals 21, we divide by 7 in order to get x is equal to 3. So the last step would be division property of equality. So for this one, they want you to solve for r. Again, I'm going to write in the statement and then the reason. I'm only going to write at this time just the given to give you guys started. Please take a few minutes and answer the question. Okay, so they're asking you to solve for r, which is, oh, I erased it, hold on. Just gonna rewrite it. They want you to solve for r. Now, in order to solve for r, you guys either have two options. You can either distribute or divide by p. I'm going to divide by p to make it easier. So when I divide both sides by p, I get r plus 1 equals, and divided by p. Because I divided, that is the division property of equality. And then the last thing I have to do to solve for r is just subtract that 1. So it's going to be r equals n over p minus 1. So it's the subtraction property of equality. Alright guys, that is it for today. We will go over the other slide tomorrow.